Hi, my name is Eric Tomasi, and I'm here to present my final project for the Spring 2019 semester of Advanced Python for Data Science. And so as a quick background, I work in the pharmaceutical industry in a team called Commercial Data Management. So broadly speaking, in the pharmaceutical industry, there's really two sides of the business, the commercial side and the clinical side. Clinical is going to be focusing on R&D and drug development and actual clinical trials, whereas the commercial side has more business functions such as marketing, legal, analytics, and sales. So one of the key challenges of the commercial side of the business is to help sales representatives determine which doctors they should actually call on, and which doctors they should be talking to about our products to help influence those doctors in their prescribing behavior. So obviously there's millions of doctors out there, and there needs to be some data analytics done to figure out which doctors are the highest priority to actually target. So there was a contest designed in which each sales representative was to target 20 different doctors in their territory, and the goal here was to recapture lost market share. So we're trying to figure out how to target doctors that are declining in my company's volume of scripts, but are increasing in some of our competitors' volume. So the goal here is to select targets in an automated and secure fashion, then plot the trends of those targets so it can be presented to senior management, and finally run a regression analysis that's going to help determine ROI and break even. So some of the motivation behind this project is really that when it was first run prior to this course, it was done in a very manual and tedious way. So I was running a lot of SQL queries, pasting that result set into Excel, manipulating it in Excel. Then requirements were changed, and I'd have to go back and rerun those SQL queries, put them back in Excel, and remanipulate them. And it was just a mess and very difficult to repeat. This is an actual screenshot of my working directory, and as you can see, there's multiple versions of some of the same files. I think there's something like 15 different Excel spreadsheets in here, and it's just going to be completely unfeasible to try to repeat this in the future. So that leads us to the goals of this project, which is one, to connect Python to the Oracle database so that SQL queries can be run behind the scenes, pumped into Python, and put into data structures such as a pandas data frame and manipulated with Python, again, to enhance some of that reproducibility. Second is to create a linear regression model to aid in determining ROI. So we have a trend of where these targets are actually going, and we would like to predict where they would be in 6 months' time, which is the end of the contest period, so that we could see if we were to do nothing, here's where we think the volume would be. And then we'll be able to observe, now that we implemented the contest, here's where the volume actually is at the end of 6 months, so we can determine what the incremental lift is. Third is to visualize trends using matplotlib. The goal here is to display the actual trend of these targets, as well as the regression trend line with the upper and lower bounds, again, to display to senior management. And lastly is a focus on reproducibility and security from end to end. That will be a common theme throughout this project. So really quick, the design of this, there's a screenshot of the new working directory. So here there's really just a handful of Python files, each of which is broken out into a different function. So there's one file that's going to connect to the database and actually load the data. There's one file which is going to apply a bunch of conditional logic to the data frame, which is essentially going to calculate point values for each doctor and sum up all of the points, and those doctors with the highest points are going to be the highest ranked in the territory, and again the top 20 based on the highest points are going to be selected for our sales representatives to actually call on. There's another file that runs the actual linear regression, one that has the matplotlib visualization, and a main.py file which essentially ties all of that together. So just to go over some of the key and interesting scenarios and use cases within some of the Python code here. First is hashing and salt. So as I mentioned, one of the goals here is security and reproducibility. So some of the corporate IDs that we have do follow certain patterns. So I wanted to make sure that these IDs are actually hashed so that they couldn't be tied back to any identifying information that would give away who an individual actually is or where they are. So this should be very familiar to everyone here. I use the SHA-256 hashing algorithm with a salt to ensure the randomness of that ID, and the return value is the last 8 digits of the hexadecimal representation of the hash. And so this was this hashing algorithm was applied to the data frame itself, so that each of the IDs was hashed in the same way. So similar to the last side, where the salt was stored in an environment variable, so too was the user, password, and actual database credentials in order to actually connect Python to the SQL database. So previously, there were a lot of Python files floating around in my company that in which the username and password was actually hard-coded into the file. So obviously not very secure and not very reproducible either for another programmer who happens to pick up that file. So using environment variables and pipenv is a great way to kind of hide those credentials in the .env file so that there's no security breaches that would happen as a result of that. So next I explored stats models. This is a package which allows you to easily run regressions and for other statistical functions. And so in the past, what I would have done is something like what you see on the left, which is print out the results of the regression. And typically I might have hard-coded in some of the values for the intercept and the slope and use that in something like Excel to actually make my predictions. Now what I'm doing in this project is what you see on the right, which is running the regression with Python, and instead of just printing out the regression results, I'm actually storing all those parameters in Python objects, or variables rather, so that they can be reused in the future. So if this regression is ever rerun, I won't have to look at the results and re-hard code anything. They're already stored in variables for future use. Another interesting thing that I explored was smoothing the data in visualizations. So I wanted to make sure that the graph is something that was visually appealing and something that was very easy to tell where the trend was going. So I wanted to smooth out the data. And to do this, I used a package from SciPy called interp1d. And so this actually uses what is called a spline interpolation. And the type which you see in the second to last line of that piece of code there is a quadratic. So that is going to give you some of those smooth curves when the trend is both moving up and down over time. And so to show what that looks like, here's actually the final output of the trend. So the dark blue line here is the smoothed data, which is the actual volume of all of the targets, and then you can see the regression line running through the middle there. The next output was to store the raw data and actually append all of the values that we're calculating. So I think, as I mentioned previously, essentially what we're doing is taking into consideration a bunch of different variables, scoring each one, and then coming up with a total point value. So you can see on the right hand side of the very last column is called total points, and that's just a sum of all the points that we scored, and all that was done using pandas and applying conditional logic to pandas data frames. And then the last final output here is the actual targets per territory. As I mentioned, there's 20 per territory. So this output here is the hashed ID and the rank of each of those hashed IDs. you'll see the count will go from 1 to 20 for each territory, and then upon the next territory it will start over and count up to 20 once again. And then really quickly, some future considerations here for this project. One is to potentially utilize a machine learning algorithm to select the targets instead of using this points-based approach. The next is to utilize more of an interactive in-browser visualization instead of just a static matplotlib chart. And then lastly is in terms of the regression analysis I did, it was more of a standard time series analysis to predict the trend, but we could look at more data and see if a linear regression is really appropriate for that, or potentially use some sort of multiple regression to have a better prediction. And then here are the references. I've got my GitHub repo here, and then a couple of documentation on the interpolation algorithm that I use from SciPy. And that should be the end of my presentation. So thank you very much for listening.